Good morning, good afternoon, good evening, depending where you're joining us from. We are here to reveal another CTF, another capture the flag. This time it's number 26. This is a follow-up to number 10, which I'll let Itzik talk about, but it's a really interesting one, and I don't want to take too much away from what Itzik is going to talk about. So Itzik, I'm going to let you lead and
Thank
yeah,
you.
talk about the challenge and then how do we solve it and so forth.
Sure thing. So yeah, challenge number 26 is a phase 2 or level 2, if you want to call it, of challenge number 10. In challenge number 10, what we had is again two views: one add message and the other get message. And the problem there was that the code was set, or the message was sanitized properly on the client side, but the server did not sanitize it. So eventually, if someone invoked the server independently, they could have inserted a malicious message, and then show message would show an alert, and you got yourself a CSS or a DOM-based XSS. Sorry. So in this one, the developer actually fixed the problem. They realized that they forgot to do sanitization on the server side, and they fixed the problem. So let's go through uh, reviewing the code for this CTF challenge. Okay. The first view you have here is add message. It's a React view that goes and invokes a message to the API add message. Then here's the HTML. Then there's the show message, which is another view, which grabs the query parameter message ID, goes and fetches it from the API get messages, and fetches the message, and then plots it to the screen. And the only thing that is HTML is the message itself, because it can be formatted. But we know that this is dangerous. So that's why the developer here, actually on the server side, on add message, in addition to actually grabbing all the information, they added this piece of code where message don't purify sanitize message, meaning that message that is malicious won't be able to get in. Okay, so that's the code. That's what the developer was trying to do.
Can you show the form?
Sure, absolutely. This
So
is the form.
this is a live form. So basically, challenge number 10 was basically the same form. The input validation was on the client side. That was
Yeah,
basically the
right.
issue. That was a very simple CTF. Most people, I think, got it. Now, this one is they added here, the developer basically fixed the problem and they did an input validation on the server like it should be.
Right. And one more thing, though, probably requirement requested to add another field, attention. Okay, so in challenge number 10, there wasn't attention, so they added another field. Not a big deal, right?
Yeah,
So the attention goes in here, and it just being grabbed from the form whatever is sent to the
gotcha.
backend. Here's the attention, it's being grabbed.
Okay. So what we have here is a developer that was told, hey, you've got an issue. Please fix your code. You have to do server-side validation. The developer went ahead, did the server-side validation, and guess what? It's still hackable.
Yeah.
So, and that's something we see over and over again, where you don't solve the root cause, you patch it. And when you patch it,
Yep.
we'll see now what's going on. Okay, so talk about this CTF solution.
Right. So the solution for this CTF is to notice that the error handling here is a little bit flawed. And why do I mean by what do I mean by flawed? You see the message is being purified here, but what if we caused an error? And let's see how we can cause an error. If we don't identify attention, the dot value will not succeed to be grabbed, and then there will be an error. It will skip the validation, or sorry, it will skip the purification. So that's the trick here, is to skip the purification and then sneak in a message that is malicious by causing an error.
Gotcha.
Okay,
So
so let's see how it's done. So the first thing we need to do is we need to avoid inserting attention. You can't do it from the UI, but from the backend, you can do it. So the solution for the CTF is that you first have to invoke a message to add message. In this message, you don't provide attention. You do provide a malicious message. And once you send it, this API endpoint returns an ID. That ID can be used to grab the message. So if we go back to our view, okay, and we say, for example, message ID equals this. Let's even open a tab to see what happens and hit hack. And then you can see that I was able to pop an alert because I was able to skip the validation, get a message in, and get the flag.
Cool.
So let's talk about some takeaways. So how do we avoid situations like this, right? So in the takeaways for this CTF are three very important ones. First of all, error handling flaws happen a lot, okay? Because if you have something down the error block, the try-catch block, and you can skip it, you can change logic. So you need to be aware that either you completely exit the functionality or you do something to remediate once the error is done. Because if you continue the flow, you can cause unexpected behavior. That's one. The second takeaway is that the flow in your app should always be implemented tightly and properly. So in this case, it was error handling, but you can have if-else situations with no else for some if, and there are cracks where you can skip specific functionality. So logic is also a big problem and can cause big vulnerabilities that you have to be aware of. And lastly, and maybe even most importantly, right? Always make sure everything is sanitized everywhere. And in this case, the developer sanitized it, but it's not enough. So for example, in this case, what I would do is also encode the outputs, meaning that even though the message sneaked in as malicious, when I plot the output and print it to the screen, I will sanitize it as well, or encode the output so that it won't cause any alert or any malicious code on the client side.
So basically, like you said, like I'm just thinking about it, like the error handling is what at the end of the day caused this. Do you think like all those scanners that are out there would have flagged something like this?
It's a good question. They get better and better. Maybe they would flag it, but here's the problem: they might flag things over flag. So if it's trained to kind of like check, or potentially problematic error handling, it would flag it, but it would flag 10 others, and you'd have to skim through it and find the right ones that actually cause any vulnerability. Obviously, it helps with patterns and it helps with practices. So I definitely think that with the scanners, you can get those ideas on where you can incorporate best practices. But I don't think it will actually catch this one as specifically malicious because it's similar to multiple others.
Yeah, it's logical bug. Like, what's malicious about it? Nothing, right? It's really a flaw in the code. I remember that recently there was in one of the tournaments that we've done, somebody tried to use ChatGPT, not ChatGPT, like some kind of AI to find the solutions. And I think I was surprised it was able to find 1 out of 6 or something like that, which is still like impressive.
Right. Because some things are captured by pattern, or if there's a malicious or vulnerable component, right? There's definitely the scanners are going to say, hey, this component has this vulnerability. You don't want to use it this way. So that could definitely be, and that's good to always have because it captures that.
Yeah. But again, this is why we're doing this. We want to train that part of the mind where developers get to understand the hacker mindset and understand how their code logic or code flow can basically put this whole code at risk. And it's super important because if we're asking our peers, for example, to do code review and they don't see it, then what does code review matter, right? Like from a security perspective, we want everybody to have this hacker mindset and understand how attackers sort of go about hacking code. And I think this is also good for QA. And for those that are new to Wizer, we have courses and CTFs like that also within the product. So go ahead, register. And if you want to try this one out, this is publicly open, right? And there's also a write-up. So you can try to solve it yourself if you're not sure how. There's this small write-up that can help you with it.
Yep. It walks you through the code and so forth. And by the way, we released another challenge today, challenge number 47. Go ahead and give it a try. It's a tricky one. Not very easy, but also not the super complex one.
Yeah, but we have 8 people that solved it. That's amazing.
Yeah.
Wow.
We
Cool.
have we have a great community that are highly trained. So we're also very proud of our community.
Nice. If anybody's looking for, you know what, I don't want to, but there are some really good coders here, like and hackers and security researchers. Our community is amazing. So and you can find them in the Discord chat, right?
Yes, exactly. So Discord chat, you can look at it here. For some reason, it's down today, but you know, we have our Discord chat server that you can join. That we'll put in the post right after. We'll put the Discord server join link that you can join our community. You'll find there great people to talk to and to DM with questions and.
Awesome. You know. Okay, great. Thank you very much, Itzik, and we'll meet next week for another CTF reveal.
Thank you very much. Thank you, Gabby.